the relevance of exothermic and endothermic reaction for our different chemical reactions, different physical changes, chemical changes, or phase changes, right? Okay, it's gonna be like that. So let's understand first that that's gonna be the relationship of delta H and gives free energy. Okay, so in this topic it cannot be denied, we can touch a little bit of thermodynamics. Really. Okay, you get the point. And we will be dealing with internal energy, the entropy of the system, something like that. And we need to understand the laws of entropy, right? The zeroth law, the first law of thermodynamics, the second law of thermodynamics, and the third law of thermodynamics. Okay, so we need to familiarize that out. Okay, to connect to this topic also. Okay, and then the first thing to do, guys, is to discuss the energy diagrams. Okay, so it's quite familiar, right? Energy diagram, especially in engineering, right? So it's gonna be like the x-axis and the y-axis. So this topic really is more of this graphing, chuba chuchu will be on the unit operations, really, and then also in the chemical reaction kinetics, rate loss, something like that. So more of graphing, chuba chuchu. Oh my gosh! Bitingog! Woo! Bitingog siya guys mga kapatid.
Okay, you get the point. That's why chemical reactions, you will imagine, why H2 is coming. Because
ako rin gapon to guys, ako mag-record akong kuan. Akong mga videos akong gi-record so that I can have revenues. Charot! Revenues talaga. Yes.
the festival already.
Okay, so I have to play so that I have revenues. Okay, so energy diagram. So we need to refer potential energy, not the kinetic energy. Why? Because the kinetic energy is an energy at motion. And it's impossible that it will just stop in order we can have the diagram. For the purpose of discussion, the potential energy is an energy at rest. We can easily picture out what will be happening to a certain object if it is at rest. Like me, I'm standing in front of you, so I am at rest. It's very easy to look at me, what's going to be happening in my eyes, in my mouth, and everything. Okay, compare if I move. Okay, you get a point. So there will be a lot of interruptions, whatever, if I will move now, because if you move, kinetic energy will be there. Okay, because you covered a distance. But for potential energy, it doesn't mean you have a distance, but only a stationary vertical distance, which is the height. Okay, that's the difference between potential energy and kinetic energy, something like that. Am I correct? Okay, maybe I'm wrong, right? Okay, you get the point? Nakakaloka. And then in the ideal gas point of view, you can remember this, guys. We have and the physics point of view. Okay, kinetic energy mga palangga. Oh, kinetic energy. Let's review because we need to connect this one also, right? Kinetic energy is equals to 1/2 times the mass times the velocity raised to the power 2. And then in the physical chemistry or physics? It's gonna be physics, right? Okay. It's gonna be kinetic energy is equals to 3/2 times universal gas constant times T. Ganon. And I don't have to compute for the root mean square velocity, right? That's not our topic. Okay. So this is our kinetic energy. Two formulas lang sa ta. Okay, actually there's a lot. Applying the Euler's theorem and transport phenomena and flow, Bernoulli theorem, like that. Okay, there's a lot that involves kinetic energy also. Okay, but we don't touch that also. That's unit operations. Okay, now we have potential energy. Okay, here in the vertical, and we have here our graph. Okay, now so if our reactant will be like this, if we referring to an endothermic environment, ganon, okay, endothermic, meaning taking end of energy, endo. Okay, taking in. Okay, you get the point. Endothermic. Endothermic. Like that. Endoplasmic reticulum. Endoplasmic reticulum is a part of the biology of the cell, in the cell membrane, and there is also endoplasmic reticulum, meaning internal, endo. Okay? And then an endothermic reaction. Okay, we have exothermic, meaning taking out or taking away the energy. Exo meaning out. Okay, so exothermic reaction. Ganon. If I will say, calculate the area of an hexagon or hexagon. How can you compute that one? Okay, calculate the size, the area of an hexagon. O, di ba nakakaloka na? No? So, balik ka itong mga prefixes, itong 10 to, ganon. Okay, 10 to the 9, 10 to the 12, 10 to the 15, ganon, di ba? O, tera, o, peta, o, hexa. So, we need to say 10 to the 15. 15 sides is an hexagon. So my question is, calculate the area of an hexagon. So you draw a polygon that has a 15 sides. Then if you don't have an idea what's in the hexagon, all about, nga. Okay, because there's problem also like that in the future that they will never say anything and just describe what kind of polygon is that. Okay, for example, easy. What is the perimeter of an octagon? Ganon. O, di ba? Nakakaloka. Okay? So, gamit din siya guys sa mga prefixes. Okay. O, katapungkuan. Sa negative, 10 to the negative 9, 10 to the negative 12, 10 to the negative 15. Ang 15 ano ito kay femto. Ganon. Ang 10 to the negative 18 kay ato. Ganon. And then, nano. Nano, then pico. Okay, if I will say, calculate the area of a femtogon. O, charot. Nakakaloka. Because we have nonagon. Okay, that's for nano. 9 sides. Okay, like that. You get the point? Ganun siya. Okay, so we have this reactant here. Ganon. So by theory, by experimental evidences, your product is higher, the potential energy of your product is higher than the reactant. Okay? And this curve here, guys, in kinetics, as far as I could remember, this is the activated complex. Activated complex. Okay? And then that is also called as saturation. Saturation ba na siya, guys? Okay? Basta nasa sa taas. Okay? You get the point? Activated complex. Or tertiary, intermediate na siya. Nalalagyan intermediate. Okay? Intermediate reaction occurs at the activated complex. Okay, intermediate reactions ba? Nandito siya po dito. So, for example, if you have you add a catalyst, right, in your chemical reaction. So, if you add a catalyst, it will never consume, but it will only speed up the rate of your chemical reaction. But the intermediate, it will be put in the in-between of the chemical reaction, but it will be consumed. Okay, it will be produced in the middle of the reaction, and it will be consumed later on. The catalyst is the reverse. Okay, so meaning to say, in every chemical reaction, there must always be an intermediates and a catalysts. Not necessarily have an inhibitor all the time. Okay, that lowers the chemical reaction. Because most of the times, we need to increase the rate of the reaction rather than lowering the chemical reaction. Because most of producing the products in businesses or factories or companies are really increasing the rate of reaction to produce the products. It's not practical always to lower the chemical reaction. You get the point? Most of the times, increasing talaga the rate of chemical reaction. Based on what I remembered, okay? Like that, generally. Okay, ganun siya. Okay? So, wala siya. So, ang imong ko ano niya, delta H, asa man ka mag-measure yung delta H. So, dili ka you should draw imaginary line. Ganon. And then, this is for the R. And there is a ganon. And then, the vertical part here will be your delta H. Positive. Ganon. Okay, the difference between the potential energy of the product and the reactant. Okay? So, bigger ang product, okay, than the reactant. Okay, now the exothermic will be the reverse. Okay, bigger ang reactant kaysa product and the delta H negative. The drawing will be like this. Okay, ganon. There's your activated complex and intermediate reaction somewhere along the way here. Okay, like that. Okay. This is very also useful, guys, especially if you are trying to recall the Michaelis reaction and Pugnale equation, Arrhenius equation in chemical kinetics. They will try to correlate the intermediate reaction because always chemical reactions, the studies of these guys. Okay, Mr. Pugnale, Michaeli, Erwin or Erin? Erin equation and also Arrhenius, something like that. These are the scientists behind chemical reaction kinetics. Okay, but we don't touch kinetics, but it's related a little bit. Okay, get the point. And then R here, and I have the product. So meaning to say, the reactant potential energy is higher than the product potential energy. Now our delta H will be here. Ganon. Delta H is negative because it is down, going down. Okay, negative. Okay? Ganon. This is only purely imagination, but through experimental evidences, by having the technology, a monitor on the screen, it will see on the, you will see this in the screen, on the monitor when you do the analysis. Okay? For example, if you add, propane with oxygen, ganon, okay? Or any, any compounds and elements, experimental evidences, okay? And it will show directly in the technology. No need to draw like this, okay? In the lab, okay? You get the point? Ganon. So, muna sineta ko. Okay? So, now we go to, saan na nasa guys? Matulog na ko. Charot! Okay, so phase changes, ganon. So, mga basic lang kayo siya guys ha. Kaya, wala na tayo time. Hindi na tayo maabot atong mga, saan na to? Mga flocculation, leaching, mga ganon. Extraction, sedimentation, centrifugation, okay, mga sa mga different process. Maabot ato, alin ta sa mga science yun. Okay guys? Okay, kato mga alin ta sa first, pinaka-science sa tanan, evaporation. Okay? And then condensation. Okay? And then we have sublimation. Okay? Sublimation. The opposite of sublimation is deposition. This is not common, the deposition. Okay? Then this is the desublimation. Meaning to say, removal of sublimation, it will become deposition. Okay? English. D means removal. Okay? Number 5, we have the fusion. Melting, freezing point, melting point, ganon, chuba-chuchu. Okay? We have also the boiling. Ganon. Kini lang siya guys, madali naman na siya. Okay? I will never include pyrolysis, okay, or what do you call this one? Pyrolysis or catalytic cracking because it is very obvious. No, it is already exothermic reaction. No need to, explain further. But this one, murag, kung anong pala, lisunon pa ni siya, murag we have to explain. Okay? First, evaporation. Charot. Kaloka. Kaya pa sa guys ha. Ay, nako, John. Evaporation. Let's say I have magputaw ko kape and then I will boil the water. Okay, in my room. Now I will make a coffee later. Okay, something like that. I will put in the beaker or a flask, graduated cylinder or whatever. Okay, or pitcher, whatever. Okay, I put water here and there's a heat here. Ta-da-da, ta-da-da. Okay, the heat will be could it be a oven or whatever, or electric plate or whatever I use. Okay, and then there's a heat here. Okay, now it's very obvious, right? You add heat. Okay, if you add heat, okay, the water absorbs heat. Okay, so meaning to say it will vaporize. Some of the molecules will vaporize into the atmosphere. Okay, and then the volume will decrease. Okay, and the molecules will go up after collision and bombarding of the atoms and particles after the strong kinetic energy. Ganon. Because there's heat, kinetic energy will be there. Okay, and then it will go to the atmosphere. Now the volume will become, lower. Oh, ganon. Okay, so to paklaro tayo, if you increase the temperature, the volume will decrease. It is Charles' law of ideal gas law. Remember, the formula is V1 over T1 is equals to V2 over T2. Right? Constant ang imo pressure. You get the point? We have the Boyle's law, the Dalton's law, the Reel's law, the Henry's law, like that, Pascal's law. Okay, you should remember that one also. Reel's law, low, chuba, chuchu in science. Familiarize that one also. Okay, like that. So it's gonna be Charles, if I'm not mistaken. Okay, because Gay-Lussac, I think it's gonna be ganun siya. So P1 over T1 and then volume ang constant ni Gay-Lussac. Tama ba ko, guys? Charot! Basta, muna na siya. Okay, anyway, I have the formulas in my brain cells. I can solve what is being required. Okay. Okay, ganon. So, adding heat, absorbing heat, this is endothermic reaction. Okay. Now, for example, if this will come out in the board examination or in examination in the future, it will say, what type of reaction is an evaporation? Libog-libugo din ka. A, reversible reaction. B, spontaneous reaction. Ganon. And then C, endothermic reaction. E, all of the above. Klaro ka siyang endothermic reaction. Because this is phase changes. Okay? Though the other also is correct, this is spontaneous, negative, positive. This is non-spontaneous, right? It's positive. So you will say this is non-spontaneous reaction. Or this is also reversible or something like that. Okay, but look at the context. This is phase change. The right term is endothermic and exothermic. Things like that also will matter. Okay, because sometimes also they will say A and B only, C and D only, all of the above, none of the above. So, maglibog na ka kay pareho ba ang non-spontaneous reaction o ang endothermic? So, hindi ka A and B. Kaya pareho naman na siya. But we are referring here phase changes, not a chemical reaction. It's only the phase change. It's not the elemental constituent. You get the point? The water will not produce another element. That's what we mean of phase change. That's why it's not a chemical change. You get the point? There's a difference, right? Ganon. Pero kung hindi ka stricto ang question, nanaan lang po, hindi ka siya stricto. Pero usually, ato dito sa pinaka-technical na doon dito siya. You get the point, mga palangga, kung siya evaporation. Papasok na ako sa evaporation. Evaporation is also called as vaporization. That's just the same because once a substance will evaporate into the atmosphere, it will vaporize. It has the ability to be vaporized. So the process of vaporization occurs. So, vaporization and evaporation is technically the same. Number 2, condensation. Condensation is the reverse of evaporation. Reverse of evaporation. This is change from gas to liquid. Okay. Normally, a lot of processes, we have this in the market or in the different industries. For example, if we produce the condensed milk like that, Alaska, condensada. Ganon. The process there is condensation. That's why condensada, meaning condensed. When it become condensed, it become a liquid. It's not a gas or it's not a vapor. So put that in your brain cells. If it is condensed, that is a liquid. Okay? Like that. So condensation, our identification, liquid is the product. Okay. Now, what will happen here? Let's apply exothermic or endothermic. Charot. Okay? Okay. Kung nakay gas, isa may hitabo. Charot. So if I have gas here, ganan. So how can it will become liquid? You will heat that or you will cool? Wala na nakalibog no. Okay? You will cool the gas to become a liquid or you will heat the gas to become a liquid? Okay, so think which is nearer. When the things are normal, what is near? Cold or hot? Things like that, okay? So we need to take out the heat here of the gas so that it will become liquid. If you take out the heat, meaning the heat is being released so that it will become a liquid. So when the heat is being released from the system, gas, now it will become exothermic, meaning the surrounding is already becoming hotter. Okay, starting from warm, then hotter, ganon. Okay, so exothermic. Okay, the surrounding become hotter, okay, and the system become colder because the heat is being taken out. You get the point? So we can say in this manner, heat is released to the surrounding like that, and heat is being given off to the surrounding, or heat is being generated to the surrounding. Ganon. So if we try to reverse, heat is absorbed by the surrounding, heat is added by the surrounding. Take note, maglibog ka kayo. Ang meaning naman sa endothermic, ano ba ito? Heat is added to the system, heat is also absorbed to the system, by the system. Ganon. Okay? Get the point? Okay. Now, I need to teach you the preposition in English. Prepositions and conjunctions. Because this is very important in understanding the phase change. Okay. The word from, to. Okay. By, when. Okay. For. Okay. And then you can also have but, beauty. Okay. And, or, like this. You get the point? These are all preposition, right? And conjunction. From, to, by, when, for, but, and, or, on, in. Okay? Like that. Out, in. Okay. Underneath. Okay. Underneath, under. Ganon. So, muna siya yung mga preposition. Okay, so this will be used also in science a lot. So, if I will say, the heat is absorbed from the system. Okay, ganon. Meaning to say endothermic is totally different when I say the heat is absorbed to the system. You get the point? Because to meaning away from the system. We say from Atunya Padong, directed toward to him or to her, something like that. Okay, ang from ang to. You get the point? Ang for then para, for. Okay, so there's a difference also between for and to. Sometimes it will be mixed up if you cannot use the correct grammar. Okay, but it's not really that important, but it's matter a lot in problem solving. Okay, or the theory. Okay, like this. For example, work done by the system. Work done to the system. And be careful to the sign, which is different when you compute. Especially in the second law of thermodynamics dealing with Clausius-Clapeyron equation. Or the, Carnot cycle. Okay, the heat engine. Computing the heat engine of heat. Carnot cycle. You remember that one? Second law of thermodynamics, right? Because the first law is talking about the calorimeter. But the second law talking about the heat engine through Mr. Sadi Carnot. Okay, that's why the PV and RT comes because of Mr. Closius Clapeyron. Okay, PV and RT. That is his contribution, something like that. You get the point? So you should know the theories, the principles, the concepts, and also the people involved in it. Not only the formulas and equations, so that you can really picture out, ganun. So that you can easily compute also by having those, you know what I mean. Okay. Okay, so that is condensation. Condensation, it's gonna be exothermic. Okay? Common sense also, because that was the reverse also with evaporation, right? So normally the reverse of exothermic is endothermic is the exothermic. Things like that also, right? Will work. Okay, now sublimation. Wow. Sublimation. What's this? Okay, from solid to gas. Hala. Solid to gas. Klaro kayo siya, guys. Okay? So what you will do to the solid to become a gas? Meaning, you also add heat and absorb heat. The heat will be here, plus heat. So this is endothermic. Okay. Any process that will produce a gas, normally, is an endothermic. Okay? You get the point? Okay. And then, number 4, deposition, the reverse of sublimation, gas to solid. Okay. The reverse, of course, lalo na kayo siyang exothermic, but let's explain first. Okay, so if this is a gas, okay, if you hit that over and over again, it will diffuse too much. Since your purpose is to make it solidified, then you will take out the heat so that it will become solidified. So it will release heat to the solid, something like release heat. And then this is exothermic. Okay? Ganon. Then if you compute also the potential energy through the graph, makuha naman sa gyapon rin mo siya. Let's say for example, you have the same mass of solid, the same mass of like this, and treat that as an example. And then you have G is the acceleration due to gravity, which is 9.81 meter per second square. We will use that because our formula of potential energy is mass times acceleration due to gravity times the vertical height. So 9.81 meter per second squared, and then the mass in terms of kilogram, so that it will become Newton, right? And the height will be meter. And Newton meter is the unit of energy. And potential energy is an energy. That's why Newton meter. Okay? So, the Newton here is very important. Okay? And then how can you convert this to kilojoules? Calorie. If you burn out, something like that. Burn out calories. So, you need to know that 1 joule is equals to 1 Newton meter. Okay? Things like that. Okay? And then convert joules to Newton meter, Newton meter to joules, and after that, calorie. 1 calorie is equals to 4,184 joules. So you can compute how many calories burned in a day by having this equation. Okay? Not necessarily with kinetic energy because velocity is there, right? mv squared, 1/2 mv squared. So normally we will use really the potential energy, not the kinetic energy, okay? Stored energy kasi ang basihan. Okay, not the, the motion. You get the point? Basta na sa itong energy diagram ng potential energy. Ganon. So, ang deposition, iwan akong nakuhaan siya ha. Exothermic, baliman siya, diba? So, fusion. Nakakaloka to sa fusion. Ano ba fusion? Charat. So, solid. What's the fusion? What's the English when you say fuse? When you fuse something. Okay, for example, 3 people will be fused into 1. The layman's term understanding of fuse. So, like that. Okay, so how can you say that? Fusion. Okay, so fusion. It's gonna be liquid to solid or solid to liquid. Okay? Think. I need to ask you because murag nakalimot sa gwa. Charot! But I think, di ba? Muna Jun. But I think this is solid to liquid. Okay? Correct me if I'm wrong, guys, ha? Okay. Solid to liquid. May Google search. Google na nyo kayo. This is what I remembered. Okay, fusion is from solid to liquid. Okay. Solid to liquid. Normally, you have to heat the solid to produce liquid, right? So this is gonna be endothermic ang fusion. Endothermic. Okay, ganan. Now, ang melting. Hala, pareho ra siya sa, it's basically the same with fusion. What's only the difference of melting? Okay, the melting is more on the different substances, particularly the metals. Okay, elements. But the fusion is limited only to the common, the common materials that you try to fuse that one. Melting usually involves in, let's say, metals, in alloying, ganon, metallurgy. Okay, but fusion is the same, but not really broad compared to melting. Get the point? But melting is more popular, huh? So it's solid also going to liquid, right? What is the melting point of water? Melting point. Mumelt siya. Okay? So, from solid, ice, for example, ice, H2O ice. Okay? To H2O liquid. Or this is H2O solid to H2O liquid. Normally, if that is an ice, you will apply heat, right? To become liquid. So that it will melt. So what is the melting point? Okay? What is the melting point of the water? You get the point? It's not 0 degrees Celsius, because if 0 degrees Celsius, it will become solid. The reverse, okay, of 0 degrees Celsius. 0 degrees Celsius is the freezing point. Okay? The reverse of liquid to solid. Okay. The point of water is 0 degrees Celsius or 32.2 degrees Fahrenheit. Okay? Or 273.15 Kelvin. These are the values of freezing point of water. And now, the melting point is the reverse. So, compute that in a reverse direction. Nakakaloka. Diba? Oh, so this is, ano siya? Guys, this is, hit mo na siya. So this is endothermic fusion. Okay? Both fusion and melting are endothermic. Okay? Ganon. Freezing. Oh, it's very clear. Okay, from liquid to solid. Liquid, solid. Okay, meaning you take out the heat. Okay, to release heat in the solid substance. So this is exothermic. Okay? You get the point? Freezing is exothermic. Boiling. Super obvious. Exothermic. Boiling. Wait, let's explain first. Okay, boiling. Okay, it's adding heat in the system. So it releases heat to the surrounding. This is endothermic. Sorry. Okay. Endothermic. Okay. Now, inside the room, this is very cold. So this is endothermic room. Okay. So if it's very hot, exothermic room. Meaning to say, I absorb the coldness. Okay. I absorb the coldness and I release the heat. Ganon. So that's why endothermic. Okay. All combustions are exothermic, huh? Okay, because it will release heat to the, to the hood, to the engine parts like that. and you will feel the heat of the, the metals, the containers like this. Okay? Dito po muna siya, guys. Unya, kung reaction po gani, guys, kato kung gitudlo ninyo, mga banding gani siya, muband gani siya pag ayaw mo na siya ang mga exothermic. Okay? Mo decompose mo to ang mga endothermic. Itong compound mo decompose na siya sa, for example, limestone, calcium carbonate decompose into calcium carbonate to CO2. So that process is endothermic. Okay? Ganun siya. Usually, one compound decomposes to several products. But if several products combine together to produce another product, that is, bonding. So that is really exothermic. So meaning to say, the endothermic involves breaking of the molecules. Okay? Or splitting of the molecules. That's why you apply heat. Normally, when you apply heat, the molecules will split, will bombard with each other, collision, having a higher kinetic energy, ganon. O, diba? So, muna siya yung pasabot. Okay, guys, nakata na ito mga exothermic. And then, if we try to show na sa mga reaction nga mag-involve ng heat, kamao na kita, diba? Okay, sa mga H negative, H positive, chuchu, ganon. Thank you so much for watching my live streaming. I hope you like it. God bless everybody. Katugon na kay ko, mga palanggang. Nagbinisaya na si June. Nakakaloka. Okay.